Hello guys, welcome to another episode of XahTalk Show. Today is 2021, and today is July 27th. So July is about to end. So voice check, yes. Video check, we are good to go. So July 27th, 2021, and San Francisco time, 2 o'clock in the afternoon. And today we are going to do lots of random things. You are going to watch my workflow, what I do. So close that Twitter. And so today we are going to code elisp. We are going to code some website, my Unicode stuff, Unicode religious and cultural symbols, Unicode, elisp coding, and Wolfram language and mathematics. I'm gonna do some mathematics. I'm gonna show. Possibly actually we are going to code one of the fantastic Wolfram language graphics. So Wolfram language coding. Okay, mathematics, fantastic, beautiful. The world of mathematics, the depth of humanity. Okay, so that's what we are going to do, and let me explain. Yeah, I think we're gonna code this. This is in Second Life. Second Life is a virtual world. It's just like a game. If you haven't seen it, it's just like a 3D game. But you go in and you build everything yourself, like the player builds everything in the Second Life world. It's a massive world. I lived there. I lived in Second Life for like 5 hours a day for like 7 years every day. I build this in Second Life. You generate, you write a Linden scripting language, which is very interesting. Which a programming language, but different from all, because this programming language is inside the Second Life virtual world. If you don't know Second Life, you might think of it as a Minecraft. Okay, I think it's similar. It's kind of similar, but I've never been to Minecraft. But Second Life, you don't have these idiotic cubes. That's what Minecraft is. The most idiotic game in the world in the last century. The most idiotic game, Minecraft. Because technology advances, we have better and better computer graphics. But then, this idiot created a Minecraft, a 3D game, where everything is made of cubes. The fucking idiots. And also the Lego, that thing, Lego thing, is the most idiotic, and it so happens that the hackers love it. All the tech geekers, like, they build a giant Lego of a real piano using Lego, or something using Lego. Most idiotic thing, Lego. Inelegant, ugly crap. That's a Lego, and also Minecraft. Okay, so in Second Life, it's kind of like a Minecraft, but you got a real more realistic. Okay, so you use Linden scripting language. In fact, I have a tutorial, and I also have. So you are looking at the Second Life. All these characters. These are the avatars. You can go in and you can build, or you can buy, or some of them are free. They are avatars, and they are the critical thing is that each and everything you see in Second Life is built by the players. It's not like other 3D games where like Quake or whatever. The vast majority, or basically all of them, 3D games. You go in, you have a world. It's already built. But in Second Life, every building, every character you see, every hair, every texture, everything. Okay, now on this page I'm focusing on avatars. So all these avatars are created by players. Okay, the players, they are not computer programmers. They are usually oftentimes they are artistic persons. Okay, so you build all kind of creatures. Okay, not just avatars, but architectures. Like I said, everything you see in Second Life, like all these, everything, the way they move, the way they look, and the way that you can also have cars and trains and airplanes and fights, airplanes. So these people, they are into, they mimic, they actually build fairly accurate versions of World War II planes. Okay, in Second Life. Yeah, there are such people, amazing people, wild, just like real life, what incredible, impossible, all kind of people. They build planes that they build models of the World War II era planes, and there's also models of the jet fighters too as well. So Pan AM is famous company. It's a big thing. It's economics. It died out, but back then Pan AM is everywhere. It's the biggest corporation. Conglomerate, and it dies out. And also, you see, and look at this one. Okay, there are people who build every model of NASA and other countries' rocket, okay, to measurable to scaled to reality, okay. Every model of NASA's space shuttle and rockets, and also Russians and other and also China. Imagine that, and also it's you might think, oh, it's easy. It's not easy. It's Second Life build system, it's like a 3D system, like you guys will know about. Do we have people? No people. I'm talking to myself. Okay. So wait, let me double check if I'm live and talking. Yeah. Okay. So in Second Life, the build system is crap. You might be familiar with Blender, but in Second Life, the build system is a crap. Also, by the way, I also have a tutorial on that. Okay, so you can see. So let me talk about random about Second Life. Okay, so these are some of the mathematical stuff. People, mathematician Henry Segerman built in Second Life. So you got the dome, the geodesic. This is actually how do you call this from the math perspective? From a normal person's perspective, you call this geodesic or geodesic dome, which is an idiotic name created by this Bucker Fuller Minister, snake oil sailor. There's a famous guy, Bucker Fuller Minister, something, that's his name, Bucky. He created the buckyball. He created lots of things, and one of the things he's pushing is geodesic domes. Okay, why is he pushing that? Because he thinks he's kind of got a vision for the future and so on. And do I have a link to it? C# photo gallery. I have a lot of photos of dooms. Okay, but actually let me show you. So let me talk random. XahTV architecture. Okay, so you can see functional programming architecture. No, we're not talking about programming language. Okay, so let's say search for geodesic dome. Okay, so I have I collect some photos of geodesic domes in Montreal biosphere. I've been actually to there. I lived there from 1986 to 1989. Montreal in Canada. So these are called, the normal terminology is geodesic domes, but that's actually the most idiotic thing. It's not, geodesic in mathematics means the shortest distance on a surface of a curve on a manifold. Okay. Anyway, it's not appropriate to call these geodesic domes. Okay. The more appropriate name would be regular polyhedron. It would be more proper to call them as polyhedron domes. Okay. Because they are essentially, almost all of them are essentially regular, based on a regular polyhedron, platonic solids. Then you project them onto a sphere, you triangulate them, and you form these domes. Okay, so we talked about geodesic domes. So let's copy. Let's go to talk show. We are starting to talk about lots of things. Okay, who? I see money. Cortez, thank you. Good afternoon. You have triggered my inner zoomer by dissing Legos in Minecraft. Other than that, I look forward to today's show. So, I was random talking about geodesic domes. Okay, fullest meanest. Let me write down some of the things we are talking about. Burke Fuller Minister. You know that guy? Do you recognize the name? I spelled the name wrong, but his name is something like that. Buckyball. Okay, so we can find the name Buckyball. In my opinion, he's a crackpot. Okay. So Buckyballs, I want to go to Wikipedia. Yeah, so Buckyball. Disambiguation, okay, Buckyball, Buckminster Fullerene, this fucking crackpot. Let me go to the guy's name. He's featured in one of Apple's Think Different commercial. The 15 years ago, 20 years ago, all famous Think Different, which is grammatically incorrect. Okay, so this molecule structure, okay, Buckminster fullerene is a type of fullerene with the formula C60. It has a cage-like, so it's a type of fullerene. What the fuck is a fullerene? Fullerene is a allotrope of carbon whose molecule consists of carbon atoms. Okay, blah blah blah. Okay, but okay, here's the guy. Here is the guy. This is a major crackpot. Okay, it's that may be too harsh. Okay, he's not exactly a crackpot in a sense of cheating people's money, but he's one of those you might say crazy guys, but not in a good way. I don't like this guy. Okay, and he also invented. These crackpots or cult leaders, usually they are fond of creating jargons, like the Perl, Larry Wall, the creator of Perl programming language. They are fond of jargons, and also similar to the Unix people, Unix philosophy, lots of things. They are fond of jargons, code, and Emacs too, meta key and so on, scratch buffer, meta key. And okay, so this guy, Richard Buckminster Fuller, in my opinion, he's a kind of crackpotish guy, but he's not a, how do you say, a criminal, or he's not a, someone who just there to get your money. But anyway, back to my point. These crackpot guys usually are fond of jargons. They invent jargons. They create a lot of jargons. For example, he created this, look at this. In his writings, publishing more than 30 books and coining or popularizing such terms as spaceship Earth. That's a Disney thing. That's a Disney dome. Okay, spaceship Earth. Dymaxion. Okay, what the fuck is the fuck? Dymaxion. Dymaxion is a term coined by architect and inventor Buckminster Fuller and associated with much of his work. Prominently, his Dymaxion house, Dymaxion car, whatever. So it's basically essentially okay. So it stands for a portmanteau of dynamic, maximum, and tension. He's into this crap. That's not mathematics. Okay, if you don't know, you might think, oh, he's a mathematician. No, he's not a mathematician. So he invented Dymaxion map, ephemeralization. Ephemeralization. Is that what I think that is? Oh God. Okay. In English we have the euphemy. Euphemy is a kind of just a gentle, nice sounding word to replace some harsher word. Like fuck. The euphemism for fuck is kind of love. Well, that's not a good example, but you know what I mean. But this Buckminster Fuller, okay, so in English there's these euphemisms, right? And he created a term, and he take it to mean that it's the ability of technological advancement to do more and more with less and less, until eventually you can do everything with nothing. This, you see, this is a great example of this crackpot, this crackpot usually have this concept, so he's saying essentially the ephemeralization is that something you can do more and more with less and less until eventually you can do not everything with nothing. It's scum. Okay, so he and synergetics. Okay, he also invented the word synergetics and tensegrity. Okay, these are also crackpot. They are semi math. Okay, they are kind of like math. They kind of not. These. Let me show you. Okay, so go read Wikipedia article. Okay, synergetics. Okay. And tensegrity, okay, the fucking idiot, the crackpot, this guy. So I despise this guy. There are several similar guys to him, there are several in historical. So he's one of the historical figures because he influenced the world, okay, and for a period he's also served as the second world president of Mensa International. Okay, Mensa. I was a member of Mensa for like 3 years because you have to pay membership every year, and I was a member so in the 1990s, and Mensa is another culty thing. Okay, Mensa people are actually not that smart. Okay, Mensa is like 10% of the top 10% of the population IQ, and today the concept of IQ and stuff is falling out of fashion. You cannot say it, but IQ is it's a critical important thing in human animals of all aspect. You look at all aspect of human animals and society, their structure, and I talked about this in recent videos. The IQ, or how smart you are, is constitute one of the most important aspect of the shape and form and structure of a human society. Okay, as IQ. But today the social justice gang, they are they don't want that because they are just doing things to gain power. So they don't want any truth. If it's true, they don't want it. That's what the social justice gang are doing. So anyway, this book, so we talked about him, and the reason we mentioned him is because we were talking about geodesic domes. Okay, that's a bad name. The proper name should be, geodesic dome is a term he kind of pushed. The proper name is regular polyhedron dome. Okay, regular polyhedron dome. That would be a proper name because all these are the central theme of all these domes is that it's based on the idea of regularity from a regular polyhedron. That's a central theme. That's why I say the proper name would be regular polyhedron domes. Okay. Now there are lots of domes in architecture. You probably know, of course, there are especially in church. The old architecture in let me show you. Okay. In church, for example, the Islamic, they also have, this is also a dome. This open dome. In church you have lots of domes. Okay, this is grand, beautiful Western cathedral. Okay, and you have arcs. Architecture. There's a lot of terminologies, but do I have a good picture of a dome? I'm not sure. But anyway, so yeah. Anyway, let's get back to the. So I was talking about geodesic domes. Okay. So why are we talking about geodesic domes? Because I was talking about how. Let's see, where is the. I was talking about Second Life. Okay, Second Life, and this mathematician built this. Not dome. It's a regular polyhedron dome, okay, not geodesic shit. Okay, so mathematician Sedgman, okay, you probably, if you are into math, you probably heard of him. He's active on Twitter, and recently he has created lots of actual physical toys. For example, these dice, okay, very good, okay. He created a dice of 120 faces, and he also created several, weird, you don't see them much. All these, for example, these you've seen a lot, but he also created, for example, some of these, okay, skew dice and slant dice, okay, skew dice and slant dice. You might think, okay, they don't look regular, they are not regular cubes, so they must be biased, but actually not. You see, so that's why I say that he's interesting. Many of things from him, Henry Segerman, is very interesting if you are the math or geek or tech head. Very interesting. And also, there's also cone. Look at this one. Funny. It's like an ice cream cone. Okay, so let's copy that. Let's copy that. So we have a record, kind of what we talked about. Okay, I have a lot of pages from this guy. Okay, so math mechanics. Okay, so he also created this kind of mechanism. This one is the most simple. You must have seen it, but he also had created the other. So this kind of thing are called linkages. Okay, linkages. You can look up Wikipedia. There's lots of information, and there's also, this is critically important, especially in the robotic age. Today we have a lot of robotics. Running dogs. From the Houston, Boston Dynamics. The dogs or any robotics. How do they run? So that is based on linkages. Okay, so so there's a branch of math that's deal with linkages. Now, do I have a Wikipedia? Okay, let's go to Wikipedia. There's a lot of math. It's a branch of math. Okay, linkages. And I also have, here, linkages, mechanical. So the most simple one is this one everyone has seen. This one is called, what's the name of this? Scissor linkages. Okay, so you have seen that, but there's more complicated, so you have to study curves, like I talked about my plane curve, the visual dictionary of plane curves, all these are linkages, but do they have complicated ones? Oh yeah, and the odometer, whatever the speedometer. And okay, so Wikipedia have quite a few examples. Linkages is quite amazing. If you like the steampunk kind of thing, linkages is critical. Especially, for example, the train, the giant iron train of 100 years ago. You have the wheel, heavy. So you need a linkage to the steam engine. They make a piston of a rectilinear motion. You need to turn a rectilinear motion into a rotation. That's a train linkage. Okay, so this is critically important in robotics. Okay, so let's copy that. Let's paste that. So we have a record of what we talked about. So we were talking about domes, and we were talking about linkages. Okay, so let's copy that. Now let's show the power of Emacs editing. Okay, so that's today's talk show topics we talked about, and why are we talking about linkages? Because we were talking about the mathematician. He actually, Henry Segerman, he introduced me to Second Life, okay, 10 years ago. By now 13 years ago. Okay, so he's on Twitter. Okay, so what I want to say, okay, so go back. Yeah, so Second Life. Okay, so we were talking about Second Life. So copy that, go back to here, paste that. Okay, Second Life, and you can airplane. Okay, you build things. There are people, very diverse, crazy people, very interesting. Usually they are very poor. One thing I learned when I lived in Second Life for 7 years, including myself, I was like poverty. Okay, poverty below poverty. and they are also programmers. These are kind of the people in Second Life. It's kind of sad to say they are the dredges, kind of they are the outskirts of society. They weird, and a lot of them are, and also many of them, significant number of them, they have problems in life. Okay, they have problems in real life. Some of them are disabled, crippled. Some of them are has cancer. Okay, I know a few who was my friend who got cancer, terminal illness. And some of them are very old ladies. There are a lot old ladies, 50, 60 years old. But in Second Life, they are pretty young, 16 slave girls. I kid you not. Because you can actually talk to them, know them, and they go on voice. So I know a few. And then a lot. There's also this girl. She is I believe, trans. He's a guy. Okay, but anyway, in Second Life, like me, we dressed as a girl. So eventually, I kind of know. So amazing. Okay, amazing, because Second Life is it's a place where you throw out reality, the problems in real life, and if you are happy in real life, if you are successful, or if you are busy, usually you got things to do, make more money or whatever. You be with your wife or girlfriend, you got, you do your work, you are happy. But usually if you are unhappy, then there it is, Second Life. They becomes attraction, because then you go in, nobody you looks like a dog, nobody know all your problems, your ugliness, and in Second Life you are beautiful. You are beautiful, my friends. So that's because so we there's no lack of charming ladies in Second Life. Okay, because every girl in Second Life is just amazingly beautiful, and the girls, they go shopping day and night. Amazing. On Second Life, they go shopping day and night. And all these artistic people. So these are kind of weird people. So what kind of group are they? They are, I don't know how you call them today, but they were like hippies in the past, or they got talent. But however, most of them, they cannot, they are not working for, they are not working. But they have tremendous talent. That's just amazing, the things they create. So they just, and so they just live in Second Life to escape real life. So everything you see remember, everything you see in Second Life is built by people, including these cybernetics. Okay, so this is an avatar in Second Life. You can buy for like $2 USD, yeah, 2 or 3, maybe sometimes $3 USD. Many of them are free. You can buy. Someone made it. And then you put on, on your avatar. Then you actually, when you walk, you actually, the legs moves like the way they are. You expect them to. So I find this quite amazing, as a technology. Because I'm into technology. I'm into, cybernetics, not necessarily, but I mean, these are topics interest me and you. So, and I also interested in math or in mechanics, so I want to know how this works and so on. And also, then people has built this cybernetic feet. Okay, so when you put that on, your avatar actually do walk like that. Okay, so then also there are people who build the Star Trek, the ATST machine, and it does move like that. So it's amazing because the technology, Second Life, you actually, I don't know how it works actually. Some of them I do know. For example, this machine. I mean, by that I mean how to actually build it. You first of all you build. So have I shown you how to build Second Life? Like Blender thing. You can, for example, I have a tutorial. This tutorial is by now 10 years old, but I show you how do you actually build in Second Life. So, so unlike Blender or whatever CAD systems software you use on your Windows, in Second Life you build you build things, house or whatever, building cars or whatever, while you are in Second Life. So Second Life is truly kind of like a virtual reality. So you are inside, then you interact with your screen, but inside the world, other people can see, just like you are seeing this. Other people can see you are actually trying to build something. So it's amazing. Okay, so you can build. Okay, so actually, so you build. Okay, so I'm talking about Second Life today. So you can build. So all these are built. Okay, it gets complicated. So this you build, but the avatars you don't build it like that. Avatar is a different thing. You usually build using 3D software outside of Second Life. Then you import it. Then you also have to create the texture. For example, in Photoshop, and then map it to the avatar, to whatever shape. So it's not easy. Okay, believe me, I tried to learn it. It's not easy. And some of these I don't know how to build avatars. Okay, for example, this thing Scorpion, this is actually an avatar. Okay, so you go in Second Life, you can buy it, $3, and you put on, and you become this mechanical Scorpion. Quite amazing. I was truly amazing. Okay. Yeah, and some of the I still don't know how they work. I mean, how do you do it? I don't know. So, but I did learn to a certain degree. I learned. For example, I told you about. I created a okay. So, I created, actually, I sell something. So, how do you say? Search XAH. Taylor Dasher. Okay, so I built a particle machine. Okay, let me tell you about that. I built a particle machine. Okay. Now, what is a particle machine? Now, okay, so let me show you. So I built several things. One of them also, I wrote a Linden scripting Second Life LS. Okay, so here is a Second Life Linden scripting language tutorial. So I teach you actually the Linden scripting language, programming language, to allows you to have all sort of interactions in Second Life. For example, here you are looking at the source code, one of the most basic source code. What does this do? This do is that when you touch it, so in Second Life, when you run into it. So you create this script, then you put this script inside a object, like a box or a paw or whatever, a physical thing in Second Life. And whenever people bump into it, it'll like print hello. That's what this script do. So it's a Linden scripting language. It's a programming language you learn. I actually learned this, and I also wrote a Emacs mod for it. Okay, so I can efficiently write Linden scripting language code in Emacs. Fantastic. Okay, so let's copy what we talked about. And Emacs LSSL mod. Okay, paste it here. Okay, so second scripting language. So you then I build. Let me tell you what I. So this is my kind of XAH productions. This is the things I sell. Okay, so this is this script. You buy it for Linden $500, which is like $2 or something, $1 or $2. You buy it, you put on your body, then you can pass through walls and other things I made. Okay, and the most complex project I'm actually proud of is this very complex XAH particle maker. Okay, so this is a machine you buy for $30 USD. Okay, Linden scripting dollars, but equivalent to 30 USD dollars. You buy it. Do we have a comment? So I don't agree with some things you say, Xah, but I'm glad you exist. We need more people like you who aren't afraid to have this dissenting opinions. Okay, I forgot what that was about, but EXWM. Oh, okay, I don't like EXWM. So anyway, so this machine, you buy it for $30 USD, then you can raise it in Second Life. So this is what you see in Second Life. Let's see, do I have a picture of myself with it? Yeah. So you see, this is my avatar, a purple cat. It's a free avatar. So, so you raise it, then you stand, you just stand beside it. It's amazing. This is 3D. Okay. So you raise this machine, then you can click around. You can click around and it will generate particles. So what is a particle? Particle is a technology. It's a technique in 3D game, in 3D computer graphics, techniques in computer graphics to create things like water, fire, smoke, fireworks, beacon or laser light or hair, or smoke. Those are not polygons. You see, those are not made of polygons. Those are particles. Those are, so water, fire, or mist, or smoke. So you have to emulate them. So the way you do that is basically, essentially, effectively, is by having thousands of little images, and these little images go about on your screen. So you have the actual. So when you see smoke, smoke ring or smoke from a chimney in a game. Now look at your game. Okay, whatever game you play. Next time you see some smoke or some some smoke or some fire in your game, that's particles. Okay, that's particles. And how is it done? Basically, it's a bunch of little images, flat, parallel to your screen, and they move about in certain way, and then they disappear, and new ones appear. So this is the technology. Particle is a technology to emulate this kind of smoke, spring, mist, and kind of thing, and fireworks, or gun, gunshot, gun blast, machine gun, there's those kind of thing. So, and what does this machine, XahTV Particle Maker? So this machine is actually a physical machine, a virtual physical machine. You raise in Second Life, then you can create the particle effect you want. Let's say you want to, whatever you are creating, a gun of a tank. Suppose you want to emulate the smoke of a tank's main gun after it fires. I don't know how it looks like, but suppose you want that. So you need particles, but you don't know how to write the code. The particle code is fairly complex. I also have a tutorial somewhere here, okay? So then you can buy my machine, $30. Then you just click, click color, whatever color you want, click the shape, how they move, then the particle will show here, okay? In real time. Like when this is like a station. You stand there, then you click about, and this is a control center, okay? You stand there, then the particle will show in real time there. When you see that's the one you want, okay? This is raining or whatever, smoke. This is the effect you want. Then you just click, press the button on the. I explained. So here's a documentation. This page is actually a documentation for this machine. So people buy it, can read it. So when you see the effect you want, you click on this button. You stamp on this button on the ground. Okay, create script. Then it will generate the code for you. Then you can just take it. You see, I wrote this about 2 months, okay, after a lot learning and stuff, I wrote this in 2 months. So this machine, this is actually a code generator, a virtual physical machine that generates code, and with interactive user interface in 3 dimension. So I'm quite proud of this. And at the height of the time, I was selling, like, I was making $200 a week, something like that. Okay, so that's the particle machine. Okay, so we don't have any people watching. 5 people, no comments. Okay, so now I think we go back to talk to. We're gonna talk whatever we were going to talk. Okay, so this page, requirements for a visualization system. So what are we going to talk about? Okay, I don't know. First of all, let me clean up the file. Any comments? So we talked about a lot of things, mostly about Second Life. Okay, so we talk about geodesic domes, math in Second Life, airplanes in Second Life, exotic architectures, mythological creatures, avatars in Second Life, and build stuff in Second Life, and Linden scripting language, the programming language in Second Life, Emacs Second Life Linden scripting language mod, and XAH particle maker. So we talked about that. We also talk about Buckminster Fuller, a kind of a crackpot guy, and Henry Sedgman, a mathematician who creates a lot of physical puzzles and interesting things. Why did I start playing Second Life? Well, because I was getting really hungry. No food, no money. So that's really bad. So that was this is a time around 2011. Sad time. So I stopped. I cannot go on, essentially. At that time, it's pretty bad. Anyway, so let's do Unicode. Okay, so there's this thing I want to do, Unicode. Okay. Now a change of topic. So let me sip my drink. So that's that about Second Life. Unless if you have any questions, ask me. Okay. So now we are going to do something else. So let me have a drink. And I talked. How long have I been talking? So I already talked for like 40 minutes. Okay. So I have a drink and let's do something else. Okay, Unicode. So this is my website. This is something I want to do. So I have a website, Unicode. As you know, just search for Unicode arrows. You can find it. So I have a script. Let's say if I type water, W-A-T, and so there is this search box written in JavaScript that allows you to search dynamically as you type all Unicode names. So if I type WAT, then you see all these characters of Unicode. All these are Unicode that contains the word WAT in their name. Okay, so you get very fun. And then if you want to detail, for example, what is this WC? That's water closet. That's United Kingdom's term for bathroom. Water closet. Do they still call it that? Kind of old-fashioned term. Okay, so then what is this? This emoji is not apparent in what it, look what it means. So you look at here, so it's water polo. Okay, so this emoji, we might say it's not well designed. When an emoji, when you look at it and you don't know what the fuck that is, then that means the emoji is not well designed. So this one is not well designed. So let's see. Let's type some random. Okay, HEX. Hex. Okay, you got all these hexagonal things, hexagrams. Okay, has a lot to do with math, history, and linguistics. Okay, depending on where you want to go. Binary number system, hexagrams. In fact, Gauss talked about it. Okay, let's say HEA, let's see what we got. Sometimes you got lots of interesting, unexpected things, okay? HEA, let's say AE, what you got? So AE is not interesting. Let's say TE, okay? TAH, okay? HA, God, what the? FI, I'm trying to find something interesting. Okay, FI, okay, you got lots of Chinese characters. FIR, okay, then you got fire and fire related things. Sometimes you find interesting things. Let's try MIN. Okay. So you have these. By the way, these are interesting. Okay, these characters. If you have not seen them, cuneiform. Okay, very interesting. You can go down here and you can see it. Where is it? Cuneiform. Okay, so special languages. Arabic, Korean, Ethiopian, Devanagari, Indian, Bengali, Tamil, Tibetan. Tibetan is also interesting. Cuneiform. Okay, there. This is a language from the aliens, spaceship language. Let's see their full glory, magnify, okay, cuneiform. Now, so what I want to do on this page, what I want to do is that you go down, you see that star. Wait, it shows up as a star. On Android, it does not show up as a star. So what's going on? So okay, let's change that. So what's going on? So let me tell you what's going on. So I want my page to be pretty, right? I've created this website, so I want it to be, good icons for the UI. So, but the one of the complexity is that when you have Unicode on the Mac, on Linux, on Windows, on Android, or on iPhone, they show differently. Because on here I see a star, right? Oh, it's great. That's what I want. But on Android, it does not show as a star. It shows as a it shows up as this character, black, boring black character. So that's a problem. You see so you have to think about that for each and every of the emoji you use. So I'm on Windows, so it looks fine. But I just checked on the Android, it doesn't show up as a star. So why? Because the character I'm currently using is this one, okay? But however, I believe on Android, this character does not show up as an emoji. It just shows up like that. And meanwhile, I think this character might show up as that. So this is a problem of Unicode, and because especially in the past 10 years, emoji is a mistake in Unicode. It's fucked up, and also it became very political. Okay, I'm not going to talk about that. It became very political, and many of the emoji, let me cover a few, okay? Many of the emojis meaning changed because certain group of people, they think if you have a emoji of a gun, that will create more violence, okay? It's idiotic, okay? That's idiotic to the extreme, and so they create an emoji. Let me show you where, okay? So let's just search for gun, okay? GON. Okay, so it's a pistol, okay? PIST, okay? So you see, here is a PIS, okay? So here is the Unicode. The Unicode's name is pistol. So pistol is a gun, okay? But Apple began it. Apple decided, we don't want to show an actual pistol because that creates violence, okay? So Apple make it into a water pistol. the scumbag Apple. So what is going on, and why am I angry? I mean, what's the big deal? It's it's pretty, it's water gun, it's fun. What's the big deal? The big deal is that you are eradicating truth. Okay, that is the most fundamental, eternal, most important element in human society. You don't want to erase truth. Okay, more or less. Okay. Now, you might say, okay, yeah, but this has nothing to do with truth. This is just the actual funny picture. Not really. You see, now if you paid attention to politics in the past, let's say 5 years in United States, then you know what I'm talking about. One thing leads to another. Okay, I'm getting into politics, but anyway, let me get back. Okay, so not just this. Okay, so emoji. Okay, so this shouldn't be done. Okay, this shouldn't be done like that. Okay, who does that? Which country forces, like by force, these ideas onto you? There is such a country, Nazi Germany. They ban certain artwork. They ban it. They do not allow it because they have reasons, this or that, good reasons. And we are seeing such an example. And not just this. Okay, this is just one of the example. There's quite a lot, and I don't want to get into because Google is going to censor my YouTube. That's a reality. Google is we are already in this era. Okay, so no comments. Okay, so let's so what I want to do with my Unicode page, let's see. We talked about random on Unicode, so let's look at my notes, see today's to-do. Okay, fix the star on the panel, Unicode stars. So let's skip that for today. Okay, so this is not too much. Let's talk about something more interesting. Write a Emacs command to sync my packages from XAH Emacs to each of the individual packages. Okay, let's do that. Some Emacs stuff. Okay, so as you know, let's see. Okay, so in the past week or two, I created a XAH Emacs mod. Okay, so so I created on GitHub. You can see XAH Emacs distro. So this is I did this live online, and now it's up. It's it's in some way usable, so you can go and download it. But now I have a problem. So you are looking at this XAH Emacs configuration. Okay, so you clone the Git, then this is what you got. Let's remove the backup file. So you clone the Git, and here is the files you get. So you have a README, you have init file, you have settings. Okay, then you have packages. So you open packages. Let's delete the backup. Okay, you open the packages, then you basically have several of my packages. Now there's a problem. You see, so these packages are the actual files in XAH. It comes bundled with XAH Emacs. But for example, let's say XAH HTML mod. Let's say this file. Okay, there is a actual Git repo of XAH HTML mod. That's not here. What happens here is just a copy. Okay, so let's go to XAH HTML repo. So Git HTML. So I have it as a bookmark. So you go diet. So let me show you. Okay, so let's hide the details. So you can see in this directory is the actual Git repo for XAH HTML mod. Okay, so you can see this. So here is a file. Here's a file, and so the problem is that the file, you see these two files, they are duplicate. duplicated in 2 places. And whenever I edit one of them, the normal way, the way it's supposed to, I supposed to edit them is that I should edit the one in the proper repo. I edit it, I make a commit, then I copy this file over to XAH Emacs, okay? Because XAH Emacs uses lots of packages. So in the XAH Emacs, I'll just say, okay, updated XAH HTML to version something. And meanwhile, for the XAH HTML file, whenever I make something, I actually say, what changed. Maybe I added a new function, I fixed some bug or things like that. So anyway, the issue is they are duplicated. So, but whenever I edit, usually I jump to, whenever I start to edit, let's say one of these, let's say XAH HTML mod, usually I directly edit the version on XAH Emacs packages. Why? Because when I press a key, it just automatically go here, because this is actually the file I'm running. So I can make a change, evaluate the code, I can see it works or not. So it's very convenient to work with the version of the package that's actually running. But there's a problem. If I do that, then I updated the one in the packages, then they become out of sync. But what I actually need to do is to modify the one in the repo. So that's a problem. So oftentimes what will happen is that you have one version of file of these packages in the repo, another version in the XAH Emacs packages. So after a while, you don't know which one is the latest. Maybe you made some change here, maybe you made some change there, then you have to do diff. Diff is one of the most time-consuming thing. Diff is really painful. So I want a solution for that. So I'm thinking what I'm gonna do is that whenever I made a change here, I'm going to write a command to automatically copy whatever the file here to the repo, okay? So let's do that, okay? Let's just do that for XAH HTML mod, okay? Let's start to write a command, okay? Close that, close that, close that, close that. Back to talk show, let's write a command. So you are looking at my workflow now. Emac this, so start to write a command, define, okay, and magnify and show the ping window and what I want to do. So XAH sync Emacs packages, okay? Let me just say that XAH sync Emacs package, okay? Version. Sync current package file to the proper git repo. Basically just copy it over, okay? So what do I do? So okay, let's open a new window. Let's see where is the, okay, so here is the directory. So XAH HTML, copy the file path. So condition. So we have a condition equal that current directory. So current file. How do you get buffer file name? Buffer file name. So if the current file I'm working on is of this path, okay? Yeah, so buffer file name. So let's try that. yeah, full file, full path. Okay, so the current, if it's equal to that, then so that's a condition. That's the first condition. Then basically copy to the proper Git repo of the XahTV. Okay, so what is that? Where is that? So here is the, so basically copy it to here. Okay, so we want to copy file copy. Okay, so Emacs copy file, copy the buffer file name to the new name. Okay, optional. Okay, if already exists. No, we want to ask. So nil. Keep time preserve. Okay. Okay, so we don't care about these options. Okay, so you can see what's going on. Prettify the code. So now it's clear. So if the current buffer file name is that, then copy over. Otherwise, then we have other conditions. The other condition will be, let me show you. Go to so the other, the other file we need to check is all these other packages. But so we need to write more code. But for now, let's just simplify. I mean, let's just give a draft example to kind of show you what I'm doing, so you can, hopefully you are learning some Emacs Lisp for those of you who are watching this for that. So condition, if it's HTML, then copy it. Otherwise, do nothing. Okay. Otherwise, true, do nothing. So let's just say that for now. Okay. Evaluate, then copy the file. Okay. Delete this file. Go back to TalkShow. Paste it here. Prettify it. Show in browser. So here we have code. XahSync Emacs package. So let's try it. Okay. Let's try to call it. So I'm gonna call it metax XahSync Emacs package. Do it. Nothing happens, I think. Okay, I need to change. Nothing happens. Okay. Evaluate it. Call it again. Do it. And it prints nothing happens. Good. Now, but however, if I'm in the HTML file, okay, so let's go to packages. Okay, let's go to packages. You see, open that. So right now I'm in the XahHTML mod file under the packages directory. Okay. And so this version, I just updated this. Let's say, let's update that. Let's give it a new number. Okay. Let's say 18. Okay. 13.18 something. Okay. And now let's go to the Git version of the HTML, the proper repo. So you see, this is 13.16, and over here is 13.18. Okay. So if I'm on this file, I'm gonna call that command. That command should copy over this file. So let's try it. XahSync Emacs package. Do it. Oh, it says nothing happened. What the? Okay, something wrong. Let's see. Okay, I don't know why is that. So let's evaluate. Let's evaluate neo. So what is the buffer file name? Why is it neo? So I'm going to, when I evaluate this, it returns neo. So let me try to see what's the output of buffer file name. So let's put it here. Control U, then eval last 6. Okay. Then I'm gonna compare this. These are the same thing. Why is it? So why does it eval? So why is it? So let's try again. Eval. It says neo. What? Oh, okay. So we don't want to use equal. We want to use because equal. Two strings are never equal. Okay, in Emacs when you use EQ. So let's try. Okay, in Emacs this. So let's say X. Okay, let's try this. So we are evaluating two strings X and X. Evaluate neo. You see, even they are the same. So instead, what you want to use is either string equal. Okay, so either you want to use string equal, or you must use just equal. So for example, if let me show you. So if we try that, T true. You see, now if we try that, that's also T. So let's change the code to the string equal here. Yeah. Okay. So we don't need this anymore. So okay, now we evaluate this code, evaluate it, and close that. Okay, now we are going to call it again. XahSync Emacs package. It should watch this. Here it should be 13.18. Okay, after I call this command, do it. Oh, then it says file already exists. Okay, yeah. So I need to overwrite them. Okay, so okay, back to modify the code. Copy file. File already exists. True. Okay, so copy file. The okay if already exists. Yeah, right over. Overwrite them. Okay, evaluate the code. Back to the here. Code again. Do it. What? File already exists. What? I thought we just told it to. Let's see. Copy file. File name optional. Okay if already exists. Right? We just said true here. Oh. Wait. Oh, okay. We put it inside the wrong bracket. Now, evaluate it. Okay. Go back to the HTML. Okay. Now call it. Do it. Fantastic. You can see. You see, it's updated there. Okay, that's something for me. This is great for me. So this helps me to keep these two duplicate files in sync, kind of. So I can, so after a while, when there's a lot of changes, I can update the original Git repo. So am I still talking? Okay, so 5 people watching now. Okay, so I talked for 70 minutes already. So let's continue. Okay, so you are just watching me work. Okay, so I need to, so this one is done. So actually I need to do others. Okay, so let me copy. Okay, so you can see now I need to go to the packages folder. What is this? Adaptive sampling. Where's the packages? Okay. Yeah. What? Confusing. Okay, now back to my Emacs code. So okay, so the other file is that okay. Wait, okay, so wait. Okay, you actually need a lot more. You know, at this point we can make the code more elegant because now it's just lots of repetitions. Actually, you need more. Okay, so clean up the code, clean it. Okay, this is probably unreadable, so let's clean up the code. Okay, so like that, and then we need to clean the second, we need to modify the second part. Okay, so let's work on like that. So now I need to go to Git. So CSS mod, where's the home page for CSS? Okay, CSS mod, there, okay. Then XahDiet, that's the package home page, XahDiet, okay. Then Emacs list mod, okay. Then find, okay. Then flag keys, okay. Then get things. Then insert random ID. You know, it's unfortunate that each one of these, their directory name is kind of inconsistent style. The naming of the directory names, you see, for each one of my packages. You know, some of them actually the directory name ends in .el. Why did I do that? Because back then, 10 years ago, when everyone is having a Git repo, when GitHub just invented, everyone is hopping into the GitHub train. And back then, at that time, JavaScript is most popular. So the question is, if I have a Emacs package, let's say this name, insert random ID, what should the GitHub's directory name be? So, back then, JavaScript also at the time is very popular. So the JavaScript convention is that when you have a project, usually you name it in .js. So for example, node.js. That's a project name, not .js. So the JS indicate it's a JavaScript project. So I thought, so maybe in Emacs we can do the same. So insert random ID, then .el. El just means Emacs Lisp, so it's an Emacs Lisp project. So that's why I have a directory. I have, for some of these projects, their directory name also ends in el, but I think it's a mistake. Depends on how you think. Okay, for example, the typical tech geekers today, the Emacs coder, typically when they look at my code, they'll say, "Oh, Xa is this weird idiot. He doesn't know how to name the directories." Those people are unthinking idiots. The common people, and they like to tell you what to do. Okay, so Xa random insert mod. So I got that. Then Xa JavaScript mod. So let's open that. Copy that JavaScript mod. Okay. Then Xa lookup. Okay. Then here is another different name. Copy that. Xa lookup. Then Xa math input. Actually I can probably do I can work this in a better way by first of all listing all Emacs Lisp files. Yeah, why not? Why don't you? Yeah, let's do that. Why don't I show you a fun way to do this? So you're gonna do the recursive. Okay, so actually we're gonna use PowerShell. Okay, so get your item recursive include anything .el, then just say name. Okay, so copy that, shrink, go to git, then paste it. Actually I don't want to run that because then you run let's say xa.el. okay, so yeah, here it will be better. Okay, so if I run it, it'll show me all .el files in my repo that includes Xa something. There it is. But actually I want the full name. I don't want the I want the full path. So I've been talking for 80 minutes. Oh wow, so what's going on? Wow. Oh, those are directories actually. Okay. Fantastic. Okay, let's copy it. Yeah, I'm fucking stupid. Let's copy it, put it here, remove the empty lines. Let's see what you got. Oh, then there's a backslash. I need to change backslash to slash. That's a pain. Oh, but I have written a command. Let's look at my command. Okay, so I'm gonna call the command. Okay, slash to backslash, slash to double backslash. I want backslash to slash. Okay, I don't have it. What? Slash to double backslash to slash. Shit, I have so many versions. You didn't see it, but if I do it now, you see I have 3 versions, but I'm missing the version I want. I want a single backslash to slash. Fucking idiot. Okay, so let's just do it manually then. What? Search string that, search string backslash slash to slash. Yeah. Backslash slash. What? query replace 1 backslash by slash. Oh, okay, just 1. Replace them all, okay? I don't know why is it, okay, so anyway, let's go back to modify the code. XahMath input. Okay, the problem with PowerShell is that it doesn't print the full path. Yeah, and I haven't figured out how it does that. Yeah, stupid. Okay, let's go back to Git then. So math input there, then find replace pairs there, then elisp utility. What? Yeah, this name, I need to change the name of that. Then XahLookup. Wait, didn't we do this before? Yeah, we did this before. What's going on? What? Okay, yeah, we did that before. Okay, so here is a code. Pretty fine. Let's see if that we got a comment. Okay, I don't really like all these extra lines. Why is it not aligned here? Okay, let's now let's call query replace rejects to replace the extra lines. Space plus replace by space plus replace by space. Do it here. Hey, space plus quote, double quote, space, double quote. Yeah, do it. Okay, so now it looks better. Also clean that. Okay, so that's that. Delete that. Go back to delete that. Go back to talk show. What is this file? Delete that. Close. Don't save. Delete. Close. That's TypeScript and JavaScript. Go to talk show there, paste it, show in browser. Prettify, show in browser. There we have it. Today's code for that thing for this Emac Lisp issue. Wait a minute. Okay, so let's put the code at the bottom. Okay, maybe that's it for today. Leocardo, hey, Leocardo. PowerShell doesn't have anything of a read link, real path kind of thing. Yes, of course. I mean, it does. But I mean, the issue I have now is that, you see, I'm in this direct. Let me magnify, okay, so you can see. You see, I'm in this user XahGit directory, and I want to list, all directories that has the name Xah as, something something el. Okay. Now, if I don't type the name, then it's gonna show kind of funky output with the directory structure and all. You see, it prints like that. Each one is, it's not like the Unix. It actually prints kind of like user readable. It prints the directory, then it prints the file with this table format. Okay, so that's not what we want. So what I want is, then you pass the parameter name, then it'll just give you a bunch of names, including directory names. It takes a long time to search. But however, you see, when it prints a name, it doesn't print the full path. It only prints the path, from connected from your current path. So you have to add the current path. It's not the full path. It prints the relative path to the current path. Okay. So you have to, so I think there's an easy way to get to print full path. So basically you have to, first of all, let's say file only, okay? File, okay? So this way it only print files, not directory. Okay, and let's do it. I have lots of crap, so it takes a while to. I have lots of crap in my Git directory, I think. So now you see it only prints files, okay? And now let's use the name option, okay? Name option. So it doesn't print this table format. It just prints the names. But still, they are relative path. Why is it taking a long time? This shouldn't. This is, Git directory is on a flash drive. Okay, so it's done. You see, now it didn't print those directory names. Okay, so now you have relative path. So if you actually want the full path, you have to pipe it to, and you have to remove the name, then you have to pipe to something full path, something like that, okay? I don't know, get path, okay? Get path. Okay, there's no such. I don't know, that, it's different from Unix shell. So I'm pretty sure it's trivial. You just maybe I don't think it's an option. You just pipe it to something. But I'm new to PowerShell, so I don't know. It's the main thing is that it's different from Unix. So it's not like, oh, it cannot do it, or something, oh, it's painful. It's just different from Unix. In the same way that if you are used to PowerShell, then you start to use Unix, then you have a lot of problems. The Unix, so in general, in my opinion, PowerShell is far more superior than the Unix Bash or TC shell or Z shell. Far more superior. The name, so is there the name? So let's there is no such thing as the name, pwd. Okay, so let's actually, so maybe I can find the solution. So there is pwd, which prints the current path. Okay, so what do you want to, I think actually I know I can do it. Okay, join path, so you just say join, okay? Join string, okay? Join string pwd, then maybe that, okay? Why is it taking so long? This is taking too long. I print nothing. Oh, okay. So pwd is anyway, I'm not going to do this. What's the next thing I want to do? Oh, well, the next thing is that I want to talk about Wolfram language, Mathematica. But we already talked for 90 minutes. So I think I'm going to stop here today. Yeah, so I wanted to talk about Wolfram language because yesterday and the day before we did a lot Wolfram language, and it's been 20 years since I've been coding it every day, and it's truly spectacular. It was 20 years ago, and it is still today. Essentially, it's a magnitude better than all existing languages. It was true in 1990s, and it's just true today. So in 1990s, basically the most, there's not much out there. The highest level language is Perl, and you also have MATLAB. You have several other math software as well, but they are not comparable. Okay. And today, after 20 years, you have lots of languages. You have Haskell. Haskell exists in 1990s as well. So, but anyway, today you have Haskell, Julia, Erlang, and one bunch of so many Nimrod, Golang. You have Rust. You have these are low-level languages, but you also have quite a lot higher level R. R, the language R, or Python. Python is getting very popular with AI and data science and so-called data science idiot. Doing a lot of math basically. So anyway, R, Python, MATLAB, you have quite a lot. Julia. Okay, Julia is a new kind of thing. But still, I look at Wolfram language now. In the 1990s, there are like 150 functions built in Wolfram language. Okay, about 150. 1,500. Okay, 1,500 or something like that. 1,200 functions built in 1990s in Wolfram language. Today you have 7,000. I showed you yesterday when I was building the Xah Wolfram mod. You have 7,000 built-in functions. Back in the 1990s, I read the manual, 1,000 pages, throughout 3 times in different years. So I essentially know all the functions, what they do. But now there are 7,000 built-in functions. It's overwhelming. I cannot, and I'm getting old. 7,000 built-in functions. I don't think even for if you are young, you just start out to become a mathematician. I don't think even today any people can actually fully know all the 7,000 Wolfram built-in functions, because they become this. I don't think you might know what they do, but you don't use them because they are in different diverse areas. Okay, and each of these built-in functions, they are truly amazing. It's reasonable to say for any one single line of Wolfram language code. Look at this one, okay? What does it do? So for example, let me show you. Let me explain my enthusiasm, or why do I think Wolfram language is a magnitude beyond all existing languages. Okay, let me start Wolfram language, okay? So let's start, let's say 3, okay? We magnify, then let's paste the code. You see, so we got a this is specularity. You see this shiny thing, interactive dynamic movement, rotation, okay? So look at this thing, okay? So what does it take? What does it take to build this? So first of all, you look at existing languages. None of them do this out of the box. Well, maybe the closest is Python. MATLAB does, okay? Then, but with Python, you have to know a lot. You have to be a programmer for a year or two, okay? In Wolfram language, this is one single fucking line, okay? White space insignificant, truly white space insignificant, okay? So let me show you this, okay? So I press the button. You see it. Let me show you some with actual more advanced formatting, okay? I mean, so what does it take to do this in other languages, okay? So years of coding, 1,000, 10,000 lines. This is, you can set the lighting, you can set the reflection, the different lighting models. You can have one or more several light sources. The lighting can be colored light sources, and you can also turn them off. And you also have ambient light, okay? Ambient light. For example, let me show you, okay, the documentation. Okay. Okay, that's too big. Hold on a second. Under 50. Okay, so let's magnify. Okay, so the lighting details. So they show you, for example, then you can specify specularity, which is kind of reflection. Okay, then you have colors on the surface. You can also change kind of the material properties of the surface, so they behave differently in reaction to light. Okay, then you can have lighting direction or whatever. Then you have lighting point, different type of light. Then you also have ambient light. Okay, lighting specification. Just to study the, and if you are a computer graphics, if you are a programmer, and your field, your research area is computer graphics, yeah, you can do this. You can do this in OpenGL or whatever, OpenGL or 3D CAD modeling software like Blender or AutoCAD or whatever. Yeah, you can do that. But here the thing is that in Wolfram language, all you have to do is just type this thing. It condenses all the complexities and jargons of computer graphics, the science of computer graphics, into the most essential form. Okay, it tells you when you have a lighting, you have what are the issues of lighting: ambient light, light source, color of the light bulb. Okay, then the reflection properties of the material surface. Okay, then it specifies the whole thing. You can just say it and you can see the differences. Okay, the tremendous thing. This is why I love Wolfram language. Okay, you can experiment. You can play with it. For example, let's just copy this. Okay, actually you can just evaluate it right here. Okay, so and actually we can magnify any one of them. Okay, now a sphere is not too interesting. Okay, so in this case, yeah, okay, the lighting is fixated to the thing. So anyway, so you see all these different lighting models. Okay, so actually this is PostScript, or yeah, this is PostScript. So you see what I'm talking about, and that's just lighting. Okay, lighting is nothing. And also you can have transparency. just by this line, okay, where is the opacity, you see. Now let's say opacity 2. You see, let's say opacity 0, okay, let's see what, then you got wireframe only. Amazing, okay. That's not it, so that's incredible, just for this feature alone, where you can plot different models of lighting, and you can plot and dynamic rotation, and just for this feature alone I would spend $300, the student version, to get the Wolfram language, just for this. If assuming it doesn't do integration, it cannot do matrix multiplication, matrix equations, differential equations, all that, and artificial intelligence things, image recognition. Only for this feature alone I would pay for $300, which I did in 1990s. Okay, so in 1990s I bought it, the student version. Then I wrote some code. It was great. Then I went to work for Wolfram Research for half a year as a beginning, as a summer intern. Then I decided, it's a mistake, that I'm going to go back to college to get a degree. That was a mistake. But anyway, things happens in life. So anyway, I was going to code this. So I wanted to show you some of the more complex. Can we, for example, this one. Okay. So yeah. So this, we have this in the YouTube screenshot. So let's post that, and let me show you the typography. Okay. You see this. For example, look at this this equation. Okay. X squared plus y squared minus cc squared, and square the whole thing. Okay, now I press one button, make them make them looking typeset. Okay, fantastic. And let's say divide it. Let's just draw it now. Draw it. Okay, there's an error. That's probably a bug. Visualization core contour plot message not found. Okay, so anyway, so you got this amazing thing, so this is a contour plot. Contour plot is hard to implement. So you know how to implement contour plot? Yeah, so Raspberry Pi now bought second hand. Okay, so did you try Wolfram language? I guess you did. So do you know how to implement contour plot? Okay, so for a parametric plot like that, this is easy to implement. Okay, let's change the opacity back. So for parametric plot, it's fairly to implement. I've done that before. When in 2000s. You can write this in JavaScript. You can implement. You need a graphics engine. So in the case of JavaScript, you can use SVG. So I have I talked many times. I have a SVG tutorial, and just search for XahSVG tutorial. So for a parametric equation, for example, I don't know if you can see it. So here's 3 equations. This is one for x, one for y, one for z. 3 functions. It's easy to implement parametric plot, okay, but not the lighting and that. All those are more complex. But if you just want a bunch of polygons to plot this thing, then it's easy. If you want pretty like this, it take you 10 years. Well, a year or 2. Then you have to get into the bitmaps. Anyway. But for contour plot, it's this is an equation. Okay, so look at this thing. So you can see this is a one big equation equals to 0. Okay, one big complicated equation. In order to plot this, so what happens here? The graphics is that all those points on the surface are, they are coordinates x, y, z. And if you plug them into the equation, this equation becomes true. So all these points are the solutions of the equation. How do you do this? How do you plot this? Well, the way you do it is that you basically examine. So So a 3D space, you look at every point in a space. You begin. There are infinite number of points, but you begin with a a grid. A bunch of points on a grid, and check to see if they just plug them in the points into this equation to see if that if it's near zero or not. If it is, then that point is part of the solution of the equation. So that's the essential idea to implement contour plot or implicit equations, plotting of implicit equations. You can begin by try to do a two-dimensional one. So you have an equation of two variables, x and y. You want to plot all the solutions. You can begin to implement this for two-dimensional equation, two variables. So the essential idea is essentially trial and error. You try every point to see if they are equals to zero, or usually by to see if they are bigger than zero or smaller than some number, within a region, to see if they are near zero. Okay, then those are the points that are the solution or near the solution. Then you refine it. Then you try more points closer to, then you have some refined region. Then you try more points in those region. Then you refine and refine. Eventually, you'll find the numbers that make the equation true. So that's how you implement this. So it's spectacular. Okay. So this one, there's no opacity. Let's try 0.5. So contour plot, it takes a while because it's kind of computational intensive. So okay, so now you have a transparency. Okay, that's it. I think that's it for today. Thank you guys for watching. Fantastic. Beautiful. I find this amazing. And how do you know, let me talk about one more thing, okay? How do you find this equation? It would be fun. It would be fun to me, okay? At least for me. Just sit here and try different equations and see what you get. Beautiful. It's amazing. This is a combination of mathematics and art, literally. Yeah, so this I do find this amazing. And let me show you also, no computer stuff, do things. Wolfram is amazing. I'm not any good with math. I don't know what to do with Wolfram except copy and paste. Yeah, that's good. that's most scientists do. Actually, that's true. Most scientists, they are not programmers. So when they use Wolfram language, just like me right now, you just try, you plot things. But we haven't get into actual programming of the Wolfram language, which I will start to show in my coming talk show. So how many people are watching? I'm hungry now. I talked for close to 2 hours now. And how many people are watching? Let's see. 3 people. 5. Okay, 5. Okay, I think that's it. Let me show you one more thing. So I want to show you one more thing, like Steve Jobs do. Math. Okay, so plane curves. So where do I want to go? So, I'm going to update all these. These are pretty old. Most of them 20 years old graphics. So you are looking at, you see this is a great book, by the way. You go buy it. You are looking at, you see this, you see this, we showed this today. You see this curve is called cross cap. That's a model of projective plane. Fascinating stuff. I can explain easily, but Okay, I haven't done so before. So what's a projective plane? Okay, so normally you have a plane, and the plane we imagined intuitively is that it just goes infinite. It's flat, it's not curved. Okay, it's not curved in any way. It's just a plane, x and y, and goes infinite. Okay, now what's a projective plane? What is a projective plane? Now this surface is a model of projective plane. So what is a projective plane? Well, basically, it's a concept in projective geometry, a big branch of math. Okay, so a projective plane is just like a plane, except that if you so this is a plane, right? So if you go in one direction, you keep going, it will come back from the other side. Okay, so in other words, any line, there's no line segment. Okay, any line is just connected to, it'll come back from here. But if you go in this direction, it'll come back to over, here. That's not all. Okay, so that's one thing. The other thing is that there is a point infinitely far away. You just imagine it. Okay, there's a point somewhere outside that every line will pass it. Yeah, so you see, if you have a line here, it'll come back, over from the other side. And also this line will pass that special, not special, but there's a point infinite far away, it will pass that. And in fact, every line will also pass that point. Now that's a projective plane, or real projective plane, a two-dimensional real projective plane. Why real? Because real numbers. Okay, not complex, because there's also a version of projective complex plane. So that's an idea. But why so you might be wondering, why do mathematicians create this complex idea? I mean, it doesn't seem intuitive to you. Actually, it's quite intuitive. You'll get to know why this idea occurs when you study projective geometry. It's very natural and intuitive. Okay, so anyway, so this surface is just the model of that real projective plane. It's topologically the same. You can see that, every line, you can kind of see it. You see there are grids on this surface. You can see every grid, they connect to itself. So that's the idea of lines coming back to itself. And how shall I say it? Anyway, so I'm not so good at projective geometry. I studied long ago in the 1990s. I studied some of it, and I need to revisit. Okay, that's it. Thank you guys for watching. Yeah, that's it. Yeah, there is one more thing I wanted to show. We happen to run into this page, but there is a thing I want to show about. I'm getting tired. Let's see, algorithm. Okay, here. So this thing, okay, this spectacular. Let me show you in Wolfram language. Okay, this is another contour plot. Wait, is it? Paste it, run it. Yeah, it's take a long time. Okay, but I want to show this. Okay, so magnify. Spectacular. You see, this is, I call this Borg cube. So I can just sit here all day and try different equations. You see, there's certain structure in this thing. And imagine if you are a game, if you write for game engines, create, it will be, I think it's tremendous fun to actually create this thing in 3D game engine. So a person is like a very small inside it. So it becomes like a puzzle, a labyrinth, or, you have all these tunnels and you have to find out where you are going and how this thing partitions the space. Okay, I want to try some of the specularity thing here. So let's try it. That's it for today. Thank you guys for watching. If you like my stuff, donate, okay? PayPal, Patreon. The links are on my website. Oh, this is beautiful. This is beautiful. Pink. Shit. Oh, yeah. Fantastic. Beautiful. I'm gonna leave this for a while so that YouTube will pick this up as my screenshot. Bye guys. Jonathan Hill and Seth Tagimuti. Bye guys. And thank you, Cortez.